So here we are at the building production ready ML pipelines with Snowflake and Tecton. I'll let its presenters, Miles and Kevin, take off with their presentation. You guys can go ahead.
Hey everybody, this session is building production ready ML pipelines with Snowflake and Tecton. And I will be one of your speakers today. My name is Miles Adkins. I'm a partner sales engineer covering our AI and ML ecosystem here at Snowflake, and joined today by Kevin as well. Kevin, why don't you say hello to the crowd?
Yeah, hey everybody. Nice to meet you. I'm Kevin, co-founder and CTO here at Tecton. And Tecton is an enterprise feature store for machine learning, which was heavily informed by our learnings from Uber. I was there with my co-founder a little over 3 years ago for several years, where I was working as a tech lead, working on their machine learning platform called Michelangelo. And that's the platform that all the different data science and data engineers would use to develop and productionize machine learning and feed it into the Uber applications to drive things like fraud detection or ETA predictions or restaurant recommendations. And a ton of the learnings from that experience is what at the end of the day fed into Tecton. And that's what we're going to be chatting about today.
Yeah, and from the Snowflake perspective, super delighted to have partnered here with Tecton. We hear from our customers all over the place, all of the challenges that they have of getting models into production. And even though Snowflake is great at kind of being that end-to-end cloud data platform, there's still a few specific areas where there's some gaps. And so it's great to have a partner like Tecton to help us here. And so before we dive into kind of the functionality and the specifics of our joint integration here, I do want to set up a problem overview. And to set the context for this presentation today, a key theme that we are starting to hear over and over again, especially now that it's 2021 and enterprise ML SaaS companies have been a thing for 5 or so years now, is that, regular companies, every other company out there that these ML SaaS providers are going after are having a hard time putting models into production. And most surveys will tell you like 90% of models never see, the light of day. You have a data scientist, they grab some data, train a model, and then nothing ever happens with that. And the reasons why are kind of all over the place. First of all, there's not enough data scientists in the world, is one of the main reasons. Another one is, business owners don't trust AI. It's impossible to monitor our models in production, you name it. Now, just like how Snowflake was really a reinvention of the data warehouse for the modern age, which I will dig into a bit deeper in this session, there really has been no reinvention of the tools that data practitioners use today as the industry shifts from being BI driven to ML driven. We are still using a lot of the same technologies today when it comes to data orchestration, transformation, et cetera, that really weren't meant for use cases that require predictions and decisions to happen in real time. Okay, so what is missing here? To begin with, there's really nothing out there today that does a good job at bringing together data that is in a data warehouse with live data that is being computed in real time, whether that's a streaming process or in real time on a compute device on the edge somewhere perhaps. Now, a data scientist can probably join a few tables together to build a training data set that will better detect fraud, for example. But the source of that data comes from a place where that data has already been reconciled after the fact. It's been shoved into a data warehouse, and as he trains his model and wants to go to production, things quickly fall apart when he or she needs to go and get those live features to that model in the production environment. Lastly is this idea of feature consistency across both training and serving. When defining a feature, how do I orchestrate easily both not just the backfilling of that feature, that I need to compute for generating training data sets. But then how do I also make sure that definition of that feature is captured when I go to serve that feature into production? Kind of getting those two things in sync are it's not an easy lift. And so with using these legacy data tools combined with specific requirements that those tools weren't designed for, we really results in the following picture that you see here, where a lot of bespoke work has to be done by different groups of people over time. And this introduces major roadblocks to really scaling your AI within your organization. Now, I'm gonna let you simmer with that for a moment and give a brief overview of Snowflake, and then pass it over to Kevin to walk us through how together Tecton and Snowflake resolve a lot of these challenges that we just presented. To give a brief overview of Snowflake, Snowflake is this end-to-end complete data platform. Its 3-layer architecture enables unlimitedly scalable storage of all 3 types of data: structured, semi-structured, and unstructured data. Its 2nd layer, decoupled compute, allows you to scale on all 3 verticals, up as your data grows in size, out as more and more users kind of come online and want to work with your data, and then across as different business groups in your organization look to work with the data that they're driving for the business. And then lastly, there's the 3rd layer, the services layer, which is what we call kind of the brain of Snowflake, that manages governance, security, things like query optimization and data sharing. And most importantly, for it to be delivered as a service based on your infrastructure cloud of choice. And so, kind of all combined, what this enables is really 6 distinct workloads that span not just only many of the components of a machine learning lifecycle, but many others as well. And so even though we have all this data in one place, we have kind of this single source of truth, one copy of the data in Snowflake. We have really unlimited infrastructure resources on both the storage and compute side. There still lies a gap between ML and data. And the question is kind of, how do we bridge this gap between the two when we still need some help generating things like point-in-time correct training sets, and also kind of serving data at high concurrency and low latency to our models? And so this is where we have partnered with Tecton. And so with that, I'm going to pass it over to Kevin now, and he can walk you through the rest of the presentation here.
Awesome. Thanks, Miles. Yeah, so quick recap. Tecton is the layer between your models and your data. It's really the interface between the two. And what that means in practice is that Tecton is responsible for running transformations against your raw data that you have stored in Snowflake, and it turns those into machine learning features, which your ML model is going to be trained on, or what your ML model is going to make predictions on. And then it categorizes those features, makes them discoverable, and ends up serving them to your training system, as well as to your serving system in a consistent way. And that's really key. That's the hard part. Like, how do you do this consistently so you do not introduce the feared train serve skew? That's what Tecton is built for. And Tecton does all of that by bringing the best software engineering practices over to the machine learning lifecycle, by really bringing the DevOps principles over, where you define features as code, version control them, and use CI/CD to roll those features out. So let's look at what that user journey specifically looks like before we actually show you a real demo of the integration. The ML feature lifecycle all starts with the creation of a new feature. And the way you do this with Tecton is completely outside of Tecton. It's in Python files that you just have on disk and typically back up by Git. And in those Python files, you declaratively define your feature transformation. And for people who have written Airflow DAX before, this may look quite familiar. where you have a simple Python function with some SQL snippet in there that describes how to use Snowflake to turn raw data that you have in raw data tables in Snowflake into machine learning ready features. And then you decorate this Python function with a feature view decorator that you see here, and tell Tecton how you want it to manage that feature, whether you want those features to be available online or offline, how frequently you want to refresh those, and all the type of good stuff. And as you ship this feature definition to Tecton, what it ends up doing behind the scenes is that it automatically now does what basically data engineers otherwise would have to do manually. It compiles the whole simple definition down to a true physical data pipeline or multiple thereof, which turn the raw data stored again in Snowflake into derived machine learning features that are now ready for training and serving. And specifically what that looks like for training is that Tecton registers a view in Snowflake that you would use to generate your training data. And here, as we see in the next slide, Tecton gives you a Python SDK that you can super simply pip install and import into any Python environment that you have in which you do your training. That could be Jupyter Lab, or it could be SageMaker, Dataiku, any of your favorite model training environments. And use that Python SDK to have Tecton basically generate a training data set for you that consists of as many different features as you'd like to select from the feature store. And then besides the Python SDK, there is also, of course, a real-time API that Tecton makes available, which is a REST API or a gRPC interface that your model serving application that's running in production communicates with to get the feature vector. So imagine you have a fraud detection model running in production behind some microservice running on Kubernetes that wants to make a fraud detection prediction by talking to an MLflow model running on SageMaker. That microservice needs to fetch a feature vector that allows the model to predict whether this transaction that's coming in right now is fraudulent or not. For instance, you may care about the user's most recent number of transactions over the last 24 hours or 5 minutes or what have you. And those are exactly the features that you'd get from Tecton. So you've got the microservice calling out to Tecton, getting a feature vector, and then you end up making a prediction and decide whether you want to reject or grant the transaction. And with that, we'll now show you a demo that our lead PM here, Matt Bleifer, who's been working on this project, prepared for you, that shows how Tecton and Snowflake were used to drive a ads serving model.
All right. Hey, let's dig in. So as Kevin just mentioned, we're going to take a look today at how we can use Tecton on Snowflake in order to productionize features for real-time machine learning models. In this case, we're going to take a look at an ads prediction problem where we have ads that we may want to show to a user, and we want to predict whether or not they're going to click on it. And so let's get started. The first thing I want to do is check out the existing set of features that are being used for this ads prediction model in my organization. And to do that, I'll just go to the Tecton web UI here and click on services on the left and check out this ads prediction feature service. So a feature service in Tecton just represents the set of features that we want to serve for a particular version of a model. And I can see down below here that we already have 6 features that we're computing, representing the user's ad impression counts over various time windows and the click counts for a particular ad partner, similarly over 3 different time windows. I can see an example curl of how we can actually hit the REST API from Tecton and get these feature vectors in real time for a given user and ad partner. And then I can also click on pipeline here and see the full end-to-end lineage of features that are being computed. We can see we're using an ad impressions data source from Snowflake here and running 2 different transformation pipelines to compute 6 features in total. Those are getting published to our offline and online store, which we then use for both training and serving. Now I can also dig in and get a better sense of any one of these features that's currently being computed. So if we take a look at this ad impressions counts feature view, a feature view in Tecton is just some transformation pipeline that's computing 1 or more features. And so I can similarly dig in and better understand exactly what transformations are being ran to compute this feature and how this data is being materialized. So for example, I can see that we have a simple SQL transformation here, followed by some built-in Tecton windowed aggregations that are efficiently computing these 1-day, 7-day, and 30-day ad impression counts. And then ultimately, we can see that this data is being published to the offline and are already being used for this model, but I want to actually add my own using some additional data sources from Snowflake. And so the first thing I'm going to do is hop over to Snowflake here, and I can take a look at the various data sources I have on the left. So I know from experience, I already have these ad impressions and users tables registered with Tecton. But something new I've noticed is there's this IP info database, which is coming directly from the Snowflake data marketplace. And it has this locations table here, which has data about different locations for various ranges of IP addresses. Now, I know that my users table has user IP information. And so I think by joining these two together, I can create some user location features that I can serve to my model. So let's go ahead and register this as a data source inside of Tecton and take a look at what it takes to define a new feature and add it to a feature set. So what I'm going to do here is hop over to what we call a Tecton feature repository. So this is just a set of local Python configuration files that we use to define our data sources, our features, and our services. Again, those sets of features that we want to serve for a model. So here I have this data sources.py file, and I can see the declarations for the existing ad impressions and users tables. But let's go ahead and extend this and add in this IP locations data source that we found in Snowflake. And we can see the configuration is pretty straightforward here. We're just telling Tecton the Snowflake account, the database, schema, table, etc., that it needs to be able to query this data source. So now that this data source is defined, we can actually build some features using it. And so I'll hop over to this features.py file here, and we can see that we have the two different feature view definitions that we saw in the web UI here, computing our user ad impression counts and our ad partner click counts. And then we'll add a third feature view down here and take a look at how we can compute these user location features. So the first thing that Tecton needs in order to register features is just the query that we're going to run to actually compute these feature values. So here you can see a query where I just joined together the users and IP locations tables or data sources that I have registered in Tecton. And then ultimately, I just select my user ID join key, my timestamp that I'm going to use for these later historical lookups for training data generation. And then lastly, the remaining columns representing the feature values that I want to be able to serve. So in this case, the city, country, and time zone for a given user. So now that we have this transformation defined, the next step is to tell Tecton how to actually orchestrate and materialize these feature values. So this decorator up top tells Tecton to use these user and locations data sources as inputs. We're going to group everything here around this common user entity, which also defines our user ID join key. We're going to tell Tecton that we want this data served online so that we can fetch it at low latency and do real-time inference. But we also want it offline for training data generation. We want this rematerialized every day to get new, fresh feature values. And then lastly, we want this data backfilled to this particular point in time. And so that's it. That's all we need to define our new set of features. But the last thing I'm going to do here is actually extend the existing feature set for this ad prediction model. And so we can see here, we have a simple list of features that we are already serving to this model. And what I'm going to do is define here a new version of this feature service, which just adds in these user location features that we just defined. So now that I've got everything defined locally, what I want to do is actually register this with the Tecton cluster. And so to do that, I'm going to run Tecton apply in my CLI here. And what this does is it tells Tecton to look at my local definitions and compare them to what's registered on the Tecton cluster. Tecton will notice that we have these new data source feature view and feature service definitions and ask me if I want to apply these changes. I'll say yes. And what we'll be able to see immediately inside of the web UI here, if we just hop over and do a quick refresh, is we have this user location feature view now registered. Again, we can click into the pipeline. We can see the full lineage and transformations that are producing these feature values. So this makes it discoverable by anyone else in my organization. And then similarly, we can see this new version of our feature service, which now includes these city, country, and time zone features. And likewise, the full end-to-end lineage of this particular feature set, including this user location pipeline. Something else that I can also see is that if we go back to Snowflake, Tecton has actually registered this feature view directly as a view inside of Snowflake. So we can see here that this user location view has been registered, and we can actually just get a preview of the data that's going to be produced. So we can see, again, the user ID, timestamp, and location columns that we care about. So all of this is registered directly inside of Snowflake as well, making it really easy to check out and explore the different feature views that have been created with Tecton. Now let's also hop over to our Tecton SDK, which is what we're going to use to generate our training data, and we can see how we can also preview and test out feature views there. So we'll go back to Jupyter Lab here, and we will open up a Jupyter notebook here and just import the Tecton SDK. And just like we ran these views directly inside of Snowflake, we can also iterate in this environment to test out our feature views using the Tecton SDK, which is just a light wrapper on top of these queries that we're going to ship to Snowflake. So here we can see, we can just grab this latest feature view that we defined and run it over a year's worth of data in order to sanity check things. And we should see something quite similar to what we saw directly in the Snowflake UI. Again, this data set with our user ID, timestamp, and location columns. And so now that I'm confident that this is producing the data that I expect it to, what I'm going to want to do next is actually generate historical training data for this new feature set. So to do that, the first thing that I'm going to do is load up a list of training events here, which represent users that were shown ads at a particular point in time, and then whether they did or did not click on it. And what I'm going to want Tecton to do is actually time travel on a row by row basis here, grabbing the feature values that were valid as of this point in time for this set of join keys. This is necessary to prevent any data leakage or training serving skew and make sure that our model quality is top notch. So to generate the training data, it's actually just 2 lines of code. I'll just fetch that set of features that I defined for my V2 service, pass in this list of training events, and then ask Tecton to get me the data frame representing those historically accurate feature values. And so behind the scenes, what Tecton is doing is constructing this training data query to do this point in time join across these feature views, and then ultimately shipping that query off to Snowflake. Snowflake is doing all the heavy lifting for us behind the scenes, and we should get back our data frame of feature values. Great, and so there you have it. We can see that we have those original training events, our new user location features, and then also all of the feature values for those various ad impression and ad partner click counts that we already had defined in our original feature service. So this is the data set that we can use to train our model off of, but let's also see how we can get this data online so that we ultimately can do real-time inference. And to do that, I'll just go back to my CLI here and hit that REST API endpoint for our new feature service here, this V2 service, and we'll ask for a particular user ID and ad partner ID. So this is a case where we have an ad that we could show to a user, and we want to get back a feature vector that we can pass to our model that will ultimately predict if the user will click on that ad. And what we can see is Tecton responds back at low latency with that latest set of online feature values that we can use to make our predictions. And so there you have it. In just a short amount of time, we were able to connect a new data source from our Snowflake account, define some features against it, register that, and make it available to my whole organization to discover and reuse. Then we were able to extend our existing feature set for our ad prediction model with our new feature view here, and ultimately get that data offline for training and then online for serving for our model. So I hope you enjoyed this demo, and thanks for watching.
Just to sum it all up, basically what you've now seen is how Tecton and Snowflake together really provide you with a full feature platform that solves the data problems around machine learning. We've got Snowflake at the core layer, the source of truth for all your raw data. Then you use Tecton to manage your ML features and to serve those ML features for training and serving purposes. And then finally, the only thing you now really need to train and deploy ML models is a data science environment like SageMaker or Jupyter or whatever your data science environment of choice is, to be up and running and build and deploy real-time machine learning applications. And then on the next slide, you see how you can connect with us if you want to try this integration out, if you want to ask more questions about Snowflake or Tecton or the integration between the two. You can find us in the PyData Slack channel. And we also have a separate Tecton Feast Slack community that I'd love to welcome you as well too.
Thank you guys very much for being part of the conference this year. And everyone should definitely check them out. You guys have anything you want to add after that?
Open for Q&A if there's any questions that we have. Yeah, I see a few here in just the chats. Maybe Kevin, question for you. Does Tecton require Snowflake, or do you have other options for a backend?
Yeah, we support multiple compute backends. Snowflake, Spark, and native Python are the main compute engines that we can use to transform raw data into feature data.
Okay, well, that's all I see here. Again, thank you from the Snowflake side.
Thank you very much.
Yeah, triple thank you guys. You have a wonderful day.